Hello, I'm Jeremy and I'm a product specialist at Abstract. In this video, we're going to look at how you can automatically remove interior or hidden geometry from a scene with InstaLOD's Occlusion Cull mesh operation. Let's have a look. Okay, so here we are in InstaLOD Studio, and you can see that I have this engine. Now, this engine comes from CAD data. It has a lot of intricate details and parts and pieces. You can see it's about 685,000 polygons. And so what's really great about CAD data is we get all those pieces and all the complex parts of the assembly. But in many cases, we don't really need all these pieces and parts for our visualization, especially if we're doing something for real time or something on the web. And so what I want to do here, you can see if I go ahead and hide some of these parts, I can go ahead and show you, these parts on the inside here. If I remove that red piece, or if I remove some of these panels, you can see that we have all this intricate detail and really, really awesome stuff on the inside here too. Now, let's say for my visualization purposes, I don't need any of the interiors of this model. So let's just say I'm not going to do some kind of exploded view, but I just want to be able to visualize this, in AR or VR or some kind of real-time interactive environment, and I don't need to see the inside of this engine. So what I can do is I can automatically remove all the inside geometry using occlusion culling with InstaLOD. And so let's go ahead and do that. So I'm going to go to my mesh operation settings, and I'm going to go and choose occlusion cull as the operation. And let's configure this here. So I want this to use the automatic interior mode. So that's automatically going to remove all the interior geometry. And for the cull strategy, I'm going to use by polygon. So we're just going to remove polygons that can't be seen, but we can also remove by submesh if we want to as well. I'm going to go ahead and configure a resolution here, and I'll talk about the resolution and also this adjacency depth as well in a moment. But let's just go ahead and have this process. Let's go ahead and remove that geometry on the inside automatically by hitting Start. So I want to talk a little bit about, how we can visualize what InstaLOD is doing in order to be able to automatically remove that interior geometry. So let's just say for the sake of, visualizing what it's doing is that we have a whole bunch of cameras looking at the object from all these different angles. And each of those cameras are trying to capture what's visible on the outside of this engine. And so we could say that these cameras might be, firing off rays onto the surface of this engine to be able to determine which polygons are visible. Now, if a camera fires off a ray and it hits a polygon, that polygon receives that ray and it knows, okay, I'm visible, I can be seen from the outside, so I won't be deleted. Now, any other polygons that haven't received a ray from a camera are automatically going to be deleted, and those are the ones that are on the inside. Now, here's something interesting about this. Let's say that our cameras have a resolution of some type. Let's say that's how many rays are being fired off from the camera. Now, if you have a very highly tessellated piece of geometry, from CAD data or a very highly subdivided model, the resolution from the camera might not be high enough to fire enough of those rays to capture all of the geometry on the outside. So what that results in is getting some holes in the result from very densely tessellated or very densely subdivided geometry. So we don't want any holes, so what we can do is we can actually increase this resolution. But when we increase the resolution of occlusion culling, that does come at a performance cost. It takes a little bit more power from the computer to be able to run the operation. So instead, what we can do is we can lower the resolution, but we can use an adjacency depth. And so what the adjacency depth does is, let's say that polygon has received a ray from the camera. We can see here we have the adjacency depth set to 3. So any 3 neighboring faces to that polygon that has received a ray, any 3 connected faces to that visible polygon are also going to be kept. They're not going to be deleted. And so you can think of this kind of like a safety blanket. It means that we can fire off less rays, we can use a lower resolution for the occlusion culling operation, and have a little bit of an adjacency depth to make the operation go a bit faster, but we don't need to fire off nearly as many rays. And we're not going to get any holes as well, as a result of the process. So you can see how combining a lower resolution with a little bit of an adjacency depth is going to get us a quick optimization workflow that gets us nice looking results. And so as you can see here, this operation has been long done while I've been explaining the operation here. And we can see that it looks exactly the same from the outside. So I'll just go ahead and hide that red part, and you can see all the pieces on the inside have been removed. And, I'll remove these side panels as well, and we can kind of zoom in here and see that a lot of this detail from the CAD data has automatically been removed here. And we have, only 267,000 polygons as a result, which is fantastic. And you might have noticed, if I zoom in here, that some of those parts are kind of floating in midair, and you can see a bit of these pieces of these fans, that have been kept. Well, that's because if I go ahead and I unhide everything here, we can actually see those pieces through the geometry here of those fans. And so this would be very tedious and intensive to try and do manually. So you can imagine how being able to automatically do this is a fantastic time saver. And so what's really great about this is you can see that the quality of the mesh has been untouched. It looks identical to the original. And that's because all we've done is just remove the polygons on the inside, but we haven't affected the quality of the outside of this mesh. So occlusion culling is a fantastic way to significantly optimize the polygon count of a scene without losing any visual quality from the original mesh. Thanks for watching this video on the automatic interior mode for InstaLOD's Occlusion Cull mesh operation, which automates the process of removing internal or hidden geometry. Now, in addition to the automatic interior mode, there's also a camera-based mode, which lets you set specific camera angles or viewpoints to tell InstaLOD what geometry is visible when running the operation. Anything not seen by those cameras will be automatically removed. So be sure to check out our next video on occlusion culling for more details on that mode for occlusion culling. And to make sure that you don't miss out on that video, consider subscribing to our YouTube channel. Here, we have an ever-expanding library of videos covering the ins and outs of InstaLOD. And check out our community forum and Discord server where you can ask questions, share your workflows and results, and engage with members of the InstaLOD community. Well, that's it for now. Thanks for watching, and we'll see you in the next video. If you enjoyed this video, drop us a comment below, and don't forget to subscribe. For the latest news about InstaLOD, please visit our website and follow us on Twitter. You can find all the links in the video description below. Thanks for tuning in, and we'll see you in the next one.